Alright guys, welcome to this page of the notes, and what we're going to do here is I am asking you to find the line of reflection. Now, real quick, a couple of things about the line of reflection. Remember we said that whenever you are given an image, or the pre-image and its image, so the pre-image, what you start with, and then the image, in this case the reflection, right? Across the line of reflection, both of the figures are going to be the same distance from the line of reflection, right? Think about looking at yourself in a mirror, right? However far you're standing from the mirror, your image in the mirror would appear to be at the same depth into the mirror, okay? Right, so the idea is if this is my pre-image and this is my image, the line of reflection is going to split right down between those two figures, right down the middle. All right, I'm trying to find the middle point, which brings us to midpoint. Now, these problems are going to require a little bit of algebra. That is okay. I told you every time I get an opportunity to in geometry, we're going to practice our algebra, all right? Geometry still relies on algebra, even though we're building on top of that algebra by adding theorems and definitions and postulates and things like that. The algebra is still really sort of the foundation, the base on which we're building our understanding of geometry. So what we need is a midpoint, and here's the reason why. I'll explain it to you in the first one, and then we'll take a look at it. Go ahead, work ahead, try them on your own. Come on back and try these then with me. We're going to pick 2 points, all right? I want to pick, well, I need to do at least 2 vertices. Please feel free to do it for all 3. It should work. If the algebra doesn't work out, then you probably made a mistake somewhere else, right? So it's a great way to check, but you need at least 2. We need to check 2 of the vertices, and I'm getting ahead of myself. I'm probably confusing you, so just here we go. Watch this. If I take, let's call this right here point A, that's vertice A, and this one right here, vertice B, and this one right here, vertice C. Then on my reflection, this right here would be A prime, B prime, and C prime. Now, I'm just going to draw a line in there which I'll erase because this won't actually be the line of reflection, but I imagine it looks to me something like right through there, right? Now, I'll erase that because I'm actually going to find the line of reflection, right? But my line of reflection should run right down the middle between those 2 figures, okay? The idea is this. The distance from A to the line of reflection and the distance from the line of reflection to A prime should be the same, meaning the line of reflection is the midpoint between the 2 figures. Line of reflection is the midpoint. So here's what we're going to do. We're going to find the midpoint between A and A prime. Let's say that midpoint is right there, right? And then we're going to find the midpoint between B and B prime. Let's say that midpoint is right, I don't know, maybe right about there-ish, right? Now, why do I not need to find the midpoint between C and C prime? Well, think about what we're trying to draw. We're trying to draw a line. And how many points do you need? What is the minimum number of points needed to draw a line? 2. I absolutely could find the midpoint between C and C prime, but it would only further be evidence that is not required, just additional evidence to show that I have indeed found the line of reflection, but it's not necessary. I only need 2 points, so we're only going to do it for 2 of the vertices, right? I can't do it for 1 because there's several ways to draw a line through 1 point. We looked at that back in chapter 1, but there's only 1 unique line that goes through 2 points. So I only need to do it twice. I don't have to do it 3 times. I could, but it's doing work that I don't need to. So here we go. I'm going to find the midpoint between A and A prime, B and B prime. I'm going to plot those midpoints. My line of reflection must go through those 2 points. Here we go. A and A prime. A is at -2, 0. -2, 0. A prime is at, let's see, 1, 2, -2. We're going to calculate the midpoint for that in just a second. Then I need to do B and B prime, or do C and C prime. Again, whatever, it doesn't matter what 2 points you pick, you're gonna get the line of reflection, all right? So you could do it for whichever one you want. I'll just do it for B, because, I don't know, I feel like it. Feel free to do it for C instead if you would prefer. You're going to get, as long as you do the algebra right, you're gonna get the same answer I get. B is at -3, +3. B prime is at 5 - 1. And we're going to calculate the midpoint for those guys. Okay, here we go. Remember the way that midpoint works. Midpoint finds you coordinates, x and y. The way you find those coordinates is it's going to be x2 plus x1 divided by 2. That gets me the x coordinate. And y2 plus y1 divided by 2. At this point, once you know the midpoint formula, guys, it's plug and chug. Don't fat finger something on your calculator. Here we go. Okay, these are my x's. So I'm going to have a -2 plus 2. So -2 plus 2 divided by 2. My y's are going to be 0 plus -2 divided by 2. That means I'm going to be at 2. -2 plus, so that's going to be 0. 0 divided by 2 is 0, so 0. And then it's going to be a -2. -2 divided by 2 should be -1. So my midpoint for A and A prime, A and A prime, the midpoint is 0, -1. 0, -1. So that point right there. That's the midpoint for A and A prime. Now, we do it for B, right? Because there's many ways to draw a line through one point, right? But if I get a second point, there's only one unique line. So let's go ahead and do it again. Same formula, x2 plus x1 divided by 2, that gets me my x coordinate. y2 plus y1 divided by 2 gets me my y coordinate. Same formula, here we go. I am now going to have for B, it's going to be, let's see, -3 plus 5 divided by 2, that's my x. 3 plus a -1 divided by 2. That's going to be my y, right? There's my x's. There's my y's. The midpoint is going to be at -3 plus 5 would be a +2. 2 divided by 2 is 1. 3, that's going to be 2. 2 divided by is 1. So it's at the point 1, 1, 1, 1. There's the midpoint of B. Draw that line of reflection through that guy. There it is, my unique line. And here's what I ask you to do. I want you to graph the line of reflection. Done. I want you to give its equation in slope-intercept form. Guys, remember, slope-intercept form is this. Y equals mx plus b. M is the slope of the line, rise over run. B is the y-intercept. Where does it cross the y-axis? Let's go ahead and do both of those. We have y is equal to rise over run. I'm going up 1, 2, over 1. So it's rise of 2, run of 1, 2 divided by 1, 2. So my slope is 2, that's m. So 2x. Now I just need my y-intercept. My y-intercept is at -1. So the equation for my line of reflection is y equals 2x minus 1. That is the equation, slope-intercept form for that line of reflection. Again, remember the line of reflection, if we were to go ahead and spin that guy, it should take my image or my pre-image and reflect it over to my image. All right, guys, that's the way this works. Again, a lot more algebra going on here. To find it, you've got to be able to use the midpoint formula to get 2 points. Once you've got 2 points, you've got your line, and then writing the equation of a line. Find the slope, find the y-intercept, plug them in. M is the slope, B is the y-intercept. Let's try a couple more of these together. Now that we've kind of got the hang of it, we'll go a little quicker here. All right, here's what I've got. Right there, we'll call that one, boom, we're going to call that A, so which means that this is going to be my A prime. I'm going to call this one down here B, which means that this one is going to be my B prime. Again, you could do any points you want to, all right? You don't even have to do the same ones that I do. You should get the same answer as long as you do your algebra correctly. A is at the point -5, -1, -5, -1. A prime is at 3, 3. Okay, B is at 5. I get 5, -1. And B prime, sorry, B prime is at 5, -1. B is this guy down here, which is actually at 1, 2, 3. So 3. -5. All right, there we go. So now I've got my points, A prime, B, and B prime. Again, I'm looking for the midpoint, right? What is the midpoint between A and A prime? What is the midpoint between B and B prime? If I can find the midpoint, draw my line through those 2 points, I have my line of reflection. So here we go, midpoint. Okay, it's going to be x2 -5 plus 3 divided by 2. The y is going to be y2 plus y1 divided by 2, so -1 plus 3 divided by 2. Midpoint is going to be at, let's see, that's going to leave me with a -2, so -1. Right? -5 plus 3 is a -2. -2 divided by 2 would be a -1. That's going to leave me with a +2 divided by 2, which is a +1. So it tells me the midpoint for A and A prime is at -1, 1. -1, 1. That does not look right. Oh, shoot, man. That's why it's always good to think about what you're doing before you do it. I totally screwed this up. Hopefully you caught my mistake. If you did, well done. I apologize. I'm thinking ahead of where we're actually at, and it's making me make mistakes. That is a -3. Now here we go. It's going to be a -5 plus a -3 divided by 2, and then it's going to be -1 plus 3 divided by 2. All right, so now -5 and a -3 will be a -8 divided by 2 should be a -4. That sounds a lot better. That is still going to wind up being a +1. Let's see what this looks like. Yes, I like that actually. That looks really good to me. That does look like the midpoint between A and A prime. Again, I apologize for that mistake. Let me double check my points here before I do any math just to make sure I got them right. B is at 1, 2, +3, -5. Good. B prime is at +5. Okay, it looks like I got those ones correct. Here we go. Let's find our midpoint. Okay. 3 plus 5 over 2. And then it's going to be -5 plus a -1 over 2. Midpoint is going to be at, oh, that's going to be a +4. +4 and a -4. Nope, no, not a -4, -3. Let's see how that looks. 1, 2, 3, 4. 1, 2, 3. Oh yeah, I'll definitely buy that. That looks good to me. That definitely does look like a midpoint to me. Go ahead, draw your line of reflection through those 2 points. Again, I apologize, I am freehanding this. Let's see how it goes. Yeah, sure, I'll take that. That works. It looks like I've gone through those 2 points. Now, I ask you for the equation of a line. Remember, it is y equals mx plus b. What is the slope? What is the y-intercept? Okay, I did not draw, actually here, let me see if I can fix my line a little bit, because I didn't quite hit it. Again, if you're real careful there drawing your line between those 2 points, what you're going to see is where you cross the y-axis at. So it looks like I'm crossing the y-axis right there at -1. I'll double check that to make sure it is accurate. First, let me get my slope. So from point to point, I'm going up 1, 2, 3, 4. That is a rise of 4, and then a run 1, 2, 3, 4, 5, 6, 7, -8. So right now I have an M that is a rise of 4, right, and a run of -8. Reduce that fraction, it's going to be -1/2. So I have a slope, y equals -1/2 x. Now double check the y-intercept. If I go from here, right, it's up 1, back 2. So up 1, 1, 2. Up 1, 1, 2. And indeed, I do cross the y-axis at -1 if I just go through there and plot a couple additional points to try and find that y-intercept. That is actually where it crosses. So again, you won't be graded on your drawings, but if you draw as accurately as you can, you could check by the slope to find the y-intercept, or if you draw it accurately enough, your line will cross at your y-intercept. And I won't make it anything crazy. I'll make it as simple as I can. I'm not trying to trick you. Just want to see if you can do the algebra. I got another one for you right here. Let's do one more together. And then we can try something new. So here we go. I got another one right here. Actually, this one looks very similar to one that we did together earlier, where you kind of got mirror images of each other, but they overlap. Anyway, let's go ahead and find that line of reflection. All I need to do is pick 2 points. Let's see, I will take this one, which I'll call point A, this one, which will be A prime. Then I like this one, B, and this one, B prime. Here we go. Again, just go slow, take your time. You saw me make a couple of mistakes because I was going too fast, wasn't focusing on what I was doing. I was thinking ahead. Try not to do that. It's easy to make those simple mistakes. I just did it, and I've been doing math for a long time. So please just be very, very careful. Here we go. A. A is at 1, 2, 3, 4. So 4, comma, 1, 2, 3, 4, 5, 6, 7. So 4, 7, that's A. A prime is going to be at 1, 2, 3, 4, 5, 6. Is at 6, 3. All right, so there's my A and A prime. Then B and B prime. B is at 2. 2, 6. That's what I count. 2, 6. B prime is at 4, 2. Let's go ahead and find our midpoint. So what we're going to wind up with is 4 plus 6 divided by 2. That's going to be my x-coordinate. 7 plus 3 divided by 2 is going to be my y-coordinate. Let's see what we wind up with. 4 and 6 is 10. 10 divided by 2 is 5. 7 and 3 is 10. 10 divided by 2 is 5. I wind up at 5, 5. Let's just check and see. We should be able to tell right away. 1, 2, 3, 4, 5. Oh, yeah. Yeah, that looks like a midpoint between A and A prime to me. I'll take that. I buy that. That looks acceptable. Add the x's. So 2 plus 4 divided by 2. That gets me my x coordinate. 6 plus 2 divided by 2. That gets me my y coordinate. 4 plus 2 is 6. 6 divided by 2 is going to be 3. 6 plus 2 is 8. 8 divided by 2 is 4. Let's check that one. I get 3, 4. 1, 2, 3. Again, I know it's kind of right there in the center of my two images, but again, we're looking for the midpoint halfway between B and B prime, and it looks good to me. Here we go. Again, check out the slope here. Look, it's a rise of 1 and a run of 2, positive 2, up 1 over 2. So let's keep going. We'll go up 1 over 2, up 1 over 2. That's the same as going down 1 and back 2. All right, we can do that. Down 1, back 2, down 1, back 2. Here we go. Awesome. Okay, write the equation of the line. Write the equation of the line. Now, take a look at this one. Absolutely, something you should be able to do. Check this out. It does not appear to cross at an integer. Please notice that I'm crossing between positive 2, y equals positive 2, and y equals positive 3. So how am I supposed to know what the y-intercept is? No problemo. Hopefully you remember from Algebra 1 the point slope equation for a line. Point slope equation for a line. Remember the way the point slope equation works? It's this guy right here. Y minus y1 is equal to m times x minus x1, right? That's the point slope equation for a line. In order to find the equation of a line using this, I need one point. Y1. Oh, sorry. Put them in the wrong order. Jeez. X1, comma Y1. There we go. So I need a point. Pick any point on the line. We just found a whole bunch of them. Pick any one you want to. And then you need to know the slope, which we already found together. So here we go. Y minus. All right, what point do I want to pick? Well, that looks like a really good point right there. Remember, that point right there is the point 3, 4. So y minus y1, which would be my 4. I could just as easily have gone with this point. Just whatever. Doesn't matter what point you pick. I'll go with this one. So y minus 4 is equal to, do you remember what we said the slope was? Do you remember? We counted up 1, so a rise of 1, and a run of 2, right? Up 1 over 2, rise over run, so 1 half. So m is 1 half, and then x minus, what is the x coordinate for my point? 3. Here we go. We're going to solve this guy by distributing the 1 half through the parentheses. I have y minus 4 is equal to 1 half x minus 3 divided by 2. You can't reduce that any. It's just 3 halves minus 3 halves. Now, subtract. It is a minus 4. Add the 4 to the other side. So y is equal to 1 half x minus 3 halves plus 4. And you're probably thinking to yourself, what am I supposed to do with that? Don't worry. You have a perfectly good calculator right here capable of adding and subtracting fractions. I have negative 3 halves. I'm adding 4. To add fractions, I need a common denominator. Since I already have a common denominator, or I already have a denominator of 2, I need this 4 to also be over 2. But algebra says whatever you add to the bottom of a fraction, you also have to put, whatever you multiply to a bottom of a fraction, you also have to multiply to the top. Let me show you all my steps. Y is equal to 1 half x minus 3 halves plus 4. I'm going to multiply that by 2 over 2. That gets me my common denominator of 2. So here we go. Y is equal to 1/2 x minus 3/2 plus 4 times 2 is 8, so that's going to be 8/2. Now, help me out. Minus 3 plus 8 plus 5. And after adding the numerators, you keep your common denominator, and cuckoo, cuckoo, look at you, you have your equation in slope-intercept form. There's my slope, rise of 1, a run of 2, and my y-intercept is at 5/2. Now, what is 5/2 as a decimal? Well, 5 divided by 2 is 2.5. Go back to the graph. Where does it look like you cross the y-axis? Should look like it's about 2.5. Not about, it is. It's at exactly 2.5 as a decimal. 5/2 as a fraction. All right, guys, head on over to the next page of the notes. We're going to try a couple of really neat problems having to do with reflection and playing miniature golf and pool. Can't wait to go through those with you, so I'll meet you on the next page.